Welcome to Level 3 NDT. Today we're going to cover the calibration procedure for the skin seam inspection on the 500 series Cessna Citation aircraft. This will be done per their non-destructive testing manual, Part 6, 533003. In order to do this inspection, you'll need a calibrated eddy current instrument. We're using an Olympus 600. You'll need a sliding probe with a driver and a pickup coil, and you'll need a calibration standard, part number 6583102-1. You'll notice on the probe itself, we have a layer of Teflon tape to allow the probe to slide smoothly over the aircraft skin. We also have a layer of Teflon tape over both the inspection and calibration areas of the standard on the butt joint section and the skin seam section to simulate paint. The first thing we do is adjust the frequency from the default setting on the instrument of 100 kilohertz to what's specified on the non-destructive testing manual, which is 7.6 kilohertz. We'll also set our gains. We'll set the gains to go simultaneously to approximately 56 decibels. And the last thing to do is set the rotation angle so that liftoff goes to the right and misalignment with the skin seam goes down and to the right. We need to null the instrument with the probe and align it on the skin seam to get the maximum signal. That tells us that we're perfectly aligned with the seam itself. So we null it there. We check our liftoff, it goes to the right. We check our misalignment and it goes down and to the right. So our phase is set properly. The next thing that we're going to want to do is set the position of the null point on the screen, instead of being in the middle of the screen, to be in the lower right hand quadrant of the screen. In order to do that, we'll select display and we'll set the position to horizontal 80 and vertical 30. Now, when we null the probe on the material, again, we're going to find the point, the maximum point, and that should be right at our null point at 80 and 30. Check our liftoff again, goes to the right, it goes down and to the right, and then we'll slide over our simulated crack. We want at least 6 vertical divisions. So we're just above that, so that's pretty much a very good calibration. We also want to verify that we get at least 6 vertical divisions on the skin seam portion of the calibration standard. So we'll have to re-null at that point, and we'll check our adjustments, our liftoff and our misalignment. So we'll go over this EDM notch and find that the amplitude is actually higher. As long as it's as high or higher than the first calibration, it's an acceptable calibration. And the next thing we're going to want to do is set an alarm. So we'll set an alarm. We'll set a polar alarm, and we're going to set it with, right now it has positive logic, so we only have the alarm if the dot goes into the box. The next thing that we need to do is set the alarm position. So we'll set it so it aligns with the null point position that we set, horizontal 80% and vertical 30%. You'll notice that when the alarm encompassed the point of the impedance plane dot on the screen, that we got the alarm. So we're going to go ahead and change the logic of the alarm from positive to negative. So now, as long as the dot's inside the alarm, inside the alarm quadrant, we don't get a visual alarm on the instrument. We'll go back to our calibration standard. You'll see that we're outside of the polar alarm now, so we have an alarm indication. We're going to go ahead and null the instrument. Check our alignment again and our liftoff, and go over our PDM notch. Again, we're over 6 on vertical, so we're good. And the last thing we want to do is set an alarm horn, so that if we're looking at the aircraft and the dot goes outside of the screen, not only would we just see it on the screen, but we can hear it audibly. So the alarm horn is set to on, but we only will hear it if the dot goes outside of the polar alarm. The last thing that we like to do is set the display so that we turn the persistence on to approximately 5 seconds, so that the screen persistence is set so that anything that happened 5 seconds ago gets erased. And that's the calibration setup for the Cessna 500 series skin joint inspection. Please feel free to reach out to us at aircraftndt.com if you have a skin seam inspection that's coming up, or if you know someone that does. Thanks for watching.